My name is Currie, and I am the CTO of MicroScaling Systems. And we produce tools to help manage containers in production. And very specifically, we produce a tool called MicroBadger, which is for managing and reporting and viewing the metadata associated with containers in production. And I do think that metadata in container is an incredibly metadata of containers is a very, very interesting subject, and that is what I'm going to be talking to you about today, by a slightly roundabout route. Because generally, I think we all agree, containers are an extremely interesting piece of technology. They're one of the most interesting pieces of technology that have come up during my entire career, actually, of 20 years in the industry. And I think what's very interesting and very unusual about them is that they have two quite distinct use cases. They are both development technology and they are operations technology. And by that, I don't mean, I'm not going to make some trite conclusion that they are DevOps technology. That's not really what I'm saying. That's not what I'm getting at. What I'm saying is they are two definitely distinct use cases. There is a use case for containers which will strongly appeal to developers, and there is a use case that will definitely strongly appeal, or should strongly appeal, to operations teams. So what do I mean by that? Well, if we step back and, so quite a few people coming in the back. If we step back and think about the dev use case, well, this is the use case that we are generally very familiar with, the use case of packaging, using Docker, usually at this stage, Docker to wrap applications, to wrap your processes, to wrap your libraries into a very easy to manipulate, easy to tool package. And it has been phenomenally useful, and it's really part of the kind of zeitgeist move towards continuous integration, continuous delivery. And it's a very clever concept. It's a very clever idea, the idea that you can wrap and then provide APIs around a whole application package and then move it easily from dev to test to production. And it's no surprise that that has been phenomenally popular with developers. And I would consider that to be a development use case. It appeals to developers now, and it's not surprising that it appeals to developers. So what do I mean by the ops use case? Because that Docker-style development use case is not the only use of containers. And to my mind, actually, it's not the most revolutionary and the most interesting use of containers. Because the same concept of being able to wrap up applications and then move them easily around from machine to machine, in the same way that Docker and the development use case for containers makes it easy to move applications from dev to test to production, it also makes it easy to move applications around inside your production environment. And by moving around, I mean effectively stopping it in one place and starting it in another place. Now, the concept of moving things around in production is not new. It's not unique to containers. You can orchestrate VMs. But VMs, you can start and stop them much, much more slowly because they're a lot more heavyweight. A container the container concept is within the kernel. It's actually a very straightforward, oddly, deceptively simple concept where you can assign permissions and resources to particular processes using C groups, using namespaces. But it all happens within the kernel, which makes it very, very fast compared to VMs. It's much more lightweight and it's much faster. So a VM you might bring up and down in minutes, but a container you can bring up and down in seconds or even potentially sub-seconds. And that makes orchestration a totally different ballgame. Really, really means that you can do massively more interesting things. And if you saw Armand's talk earlier about Nomad, all of this, the original use case, containers were invented as operations technology. They were invented to help people like Google and then ultimately folks like Netflix and Twitter to automate their data centers, make them one hell of a lot more resource efficient because, as we've just heard, physical data centers are very resource inefficient. And also by Google, by Netflix, to make their data centers a lot more resilient, to introduce automated fault tolerance. And this kind of clever, automated, self-acting, self-driving data center is the operational use case for containers, and I think it's actually the more interesting one. It's the more world-changing one. Because if you look at something like Nomad, so, I mean, the orchestrators are out there, Nomad, Kubernetes, Mesos, ECS, Swarm from Docker themselves, they will all let you achieve stuff that you cannot achieve. You just physically cannot achieve without an orchestrated and a containerized orchestrated environment. So Google are achieving 60–70% resource utilization within their data centers. Netflix are getting about 50%. You're not going to get much above. 60% is a kind of high benchmark for doing that, but it is achievable using an orchestrator like Nomad. But in ordinary data centers, according to Gartner, we tend to achieve about 10–15%. So you're looking at maybe 4 times better resource efficiency, which is not just cost saving, it's actually ecologically one hell of a lot safer for us all than having massively underutilized data centers with the power still on and the energy still being used, because we are hugely expanding the rate at which we are using data center resources. We cannot keep doing it in the way that we are, in a very inefficient way. So orchestrated, containerized workloads have the power to make a really positive difference to the world, and I do think that they are the absolutely most interesting use case for containers. So what do I mean by this? Let me show you this. If you've ever seen me talk before, you'll have seen me do this demo, because I do it all the time. I'm still in love with it, because I really want to see this world come about. I really want to see this orchestrated world happen, these more intelligent data centers. So this is a kind of example of the kind of thing you can do with a more intelligent, more automated data center. And this is not pie in the sky. This is absolutely plausible to do. This is, if you saw Armin's talk earlier, this is what he would have referred to as a custom scheduler. For Nomad. Now, this isn't running against Nomad, this is just running directly against Docker, but it could be running against any of the orchestrators. What we've done here is we have written a little toy custom scheduler to show what you can do, to show what's possible with an orchestrator. Because, so in this orchestrated world, you've got your applications containerized and able to move around from place to place, particularly your stateless ones. You've also got an orchestrator underneath, which knows where they are and can control them and move them around within your defined data center. All of the orchestrators, whether that's Nomad or Swarm or Kubernetes or ECS, they all have very clear APIs on top that allow you to write schedulers to drive what the orchestrator does to influence the placement of the workloads within your data centers. So this is written as a very basic scheduler, and we wrote it in Go. It's a couple of hundred lines of Go, and it's very simplistic. We wanted to try out to see what in the most simplistic world you could do with a custom scheduler. So what we said is, let's imagine a very simplified world in your data center where you have 2 containerized applications. One is high priority, and that's the dark blue. One is low priority, and that's the lilac there. And then we just faked up some randomized demand. So this is just randomly generated demand in red. And we gave the scheduler a task. And we said, you will win if you can tell the orchestrator to make sure there are enough of the high priority containers running in the data centers to meet the demand, which you don't know because it's randomized, and you fill up the rest of the resources that are available to you with the low priority container, the lilac one. So there we go. You can see it's winning there. It's not winning. There's a win. There's a win. It's going away from the win. There we go. There's a win again. So this is very simplified, but it gives you the kind of idea about the kind of custom scheduler you could be writing, obviously suited to your own systems, if say, you were using Nomad. So when Armin was talking earlier, he talked about custom schedulers. This is the kind of thing that you could be writing. to make your data center considerably more intelligent, considerably more resource efficient, and considerably more resilient, because it could be using this to make sure that things that particular application were always running, there was always instances, and most of the orchestrators already have built-in schedulers that will do that kind of fault tolerance for you. So this is the world that I want to see happen. I think it's extremely cool. I think it'd be absolutely excellent for this to happen. No, I'm going to have to step forward this. There we go. I think it would be absolutely amazing, and I think it will happen. Well, actually, what I'm saying is, I hope it will happen, but things can always go wrong. So this, what I'm going to talk about today, is one of the things that I think could go wrong with this, could hold it up, could slow it down, could mean that, because the future I want to see is that we get all of that development use case of all the packaging and the continuous delivery and the continuous integration for containers, and then we get this operational use case as well. So what I'm talking about today is what might go wrong with that, and what we can do to stop something going wrong with that, and to make this future happen. Because actually, oddly enough, the thing that is going to go wrong next is something that we all have the power to solve. It's not particularly complicated. It's a psychological problem, not a technological problem. And that is, I mean, once we started writing, we started playing around with these things, and we started writing these custom schedulers, we realized that they needed a lot of information. To do a good job in this much, much more complicated, much cleverer orchestrated data center environment, your orchestrator, your orchestration tools, your schedulers needed to know an awful lot about the applications that you were running. They needed to know things like, is it high priority? Is it low priority? At what time of the day is it high priority? Does it have to run within a certain time? Can I stop it? Can I run it in Germany? Can I run it in the US? Can I run 10 copies of it? Or am I then going to burst my licensing limits? There are loads and loads of bits of information that we're going to need, that dev have in their heads, that the orchestration tools are going to need to know about if we're going to get this clever, scheduled, orchestrated world. And we know that that can be difficult. We know that communications between ops and dev can sometimes be difficult, particularly when we're talking about something potentially as dangerous as this. Because, and this is obviously a massive generalization, but I think there is more than a grain of truth to this. As an operations person, my main goal in life is to protect the systems, to protect the development environment, to make sure that it stays up, that it meets the SLAs, that we don't lose data, and that we don't get hacked. That is what keeps me awake at night. That is my prime goal in life. That is my prime directive, if we're going to mix metaphors here. But as a developer, I have slightly different goals. My job is usually to create new features, to get new functionality out to customers, to change what's happening on the production systems. And if the production systems don't change, then that is a failure for me. So my prime goal as a developer is often to encourage change, to promote change, to make change happen more quickly. And these goals are not opposing goals. But they can sometimes be conflicting goals. They can sometimes be competing goals. And we need to find a way to get both sides of these two, both goals working together. Because oddly enough, within a business, actually the overall goal of the business might change. There'll be times in the life of a business where move fast and break things is actually the right thing to do. They're less worried about protection than they are about change. Because actually, if they don't get something out there, they will fail. And that's more important than keeping the systems alive. There'll be other times within the life cycle of a business where you'll want to make sure that everything stays up and is protected. So it's both of these are goals. They both need to be met. But it does potentially mean that there is a little bit of bashing of heads between dev and ops. Because at any one time, they're probably promoting, slightly motivated by different goals there. So we've talked about one way of, and I think the key way of getting to this orchestrated future, and of of building up trust between dev and ops on this and making this whole process as secure as possible is to provide more information about what a containerized application does. Now, we could do that verbally, but I love to talk, but it's not necessarily the best way of moving around this kind of information. We know that. We've moved away from just informing people verbally about this kind of complicated information because we know it doesn't work very well. We can put in documents, but again, that's not great. We've moved towards a world of putting it in code. And I think the equivalent in a containerized world is actually to bake it into the container itself. Because if you do, then you know that information will always be co-located with the container. It is in the container. It's immutable, like the container is, so you don't have to worry about it getting out of date or no longer applying to the container that you produced. And it also, I think the most interesting thing about baking this kind of information into the container is it can be read and acted upon by the orchestration tools, by the schedulers. So you don't actually have to tell ops about it at all. As a developer, you're putting the information in, and as an operational tool, you're using the information to make decisions about what goes on in the data center. So metadata, and this is really the metadata that I'm talking about. So what are the current means by which you can put this metadata into containers? So if you do produce containers at the moment, you're probably quite familiar with tags. So tags are a free-form text field that you can associate with a container. They are quite well used. They're usually used for version information. They're a free-form text field, so if you were feeling like you wanted to make it ridiculously complicated, you could put anything you liked in there, and it could be as long as you liked. But I don't think that would be great practice. In fact, if you look on Docker Hub, there is very little consistency about how tags are used, and they're used for all kinds of information passing. But so it's not enough, and it's not used consistently enough, I'd say. So maintainer, another free-form text field associated with that you can put in your Docker file, metadata associated with containers. It's usually, but not exclusively, an email address. That email address is usually, but not exclusively, for somebody who has anything to do with the container whatsoever. It is fundamentally a not very well-maintained field. And again, it is not enough. So tags and maintainers quite commonly used, but they're nowhere near enough to provide the kind of detailed information that containers do really need to have associated with them. But there is a mechanism that went into Docker 1.6, which is labels. And labels are a free-form key-value pair that you can specify as many of them as you want in your Docker file. And they are all that we need, really, to provide this metadata. They are vastly underutilized, but they are actually the correct solution for providing metadata that is within containers and exposing it to orchestrators. But they are vastly underutilized. So we did a scrape of Docker Hub public images and found about 4% have accurate labels associated with them, which is pretty poor. So for the other 96% of containers that are in Docker Hub public, the public container images, what do we know? If I was an ops person and a developer gave me one of those containers that are available on Docker Hub, and it was one of the 96% that had no labels associated with it. They maybe had some inconsistent tags, maybe had a maintainer, but fundamentally, it's really got no metadata associated with it. As an ops person, what could I tell myself about that container? What could I find out about it? Well, I could tell how many layers are in it. That's not useless, but it doesn't tell me a great deal. I could guess at the base image, but I would only be guessing because if I don't have the Docker file, I don't actually know what the base image even that a container is built from. Other than that, that's it. I know absolutely nothing about that container. It is a black box. It could contain anything at all. So ops are not really being, or wouldn't, in my mind, be being completely unreasonable in saying, well, hang on a minute, this is a bit dangerous. I would like to know a little bit more before I started to put this into production, or even more, started to just have orchestrators managing these containers in production without me even really knowing what's going on. Because in the dream world, developers would be producing containers and they would be being passed straight through to ops and straight into production and being orchestrated, and that would be fantastic. But I could see why ops would object to that. So, because who knows what's in that container? There's just really no information. Right now, judging by what's in Docker Hub, we're not in the habit of putting useful information, metadata, against our containers. So, but what if, maybe I'm just being overly fussy here, what if I completely trusted the developer? I was an ops person, and I completely trusted the developer who'd produced this container. They knew absolutely everything they were doing. They'd saved my life in the war. They were absolutely the most trusted person in my life. And they'd also done a security scan of this container that they'd produced. So it would be completely safe. Absolutely, I know it would be safe. And it's immutable. So let's face it, I know it's completely safe. I never have to worry about it. I don't have to worry. But actually, I do have to worry, because immutability is somewhat misleading. It can lull you into a false sense of security, because although nothing will change in your container, nobody will be putting, provided you've got signing as well, so you're fairly sure that your container is the container that you originally put in there and nobody's patched it. Even then, it's not safe, because we all know that exploits are found in base images all of the time. Even if a base image or any subsequent image went into your container absolutely fine and the developer had done a great job of security scanning it and making sure that it was all safe, we can't guarantee that subsequently an exploit has not been found in that container. And as an ops person, given one of the 96% of Docker Hub containers that are not labeled in any way, there'd be no way for me to tell really that had happened. I wouldn't know when it was built. I wouldn't know what code it was built from. So unless I could rescan it. But that is that's quite a complicated way of going about things. And there is a very easy solution. So given that, it's not unreasonable for ops to be pushing back somewhat on dev, or taking these unlabeled, unknown black box containers. And I can see a future in which that happens, in which maybe we get all the development advantages of containers, but it takes us a lot longer, or for some companies, we never achieve the operational advantages because of this gulf of fear and the lack of information provided potentially by developers, which I'm seeing at the moment. 96% of public images on Docker Hub are totally unlabeled, no metadata associated with them, a complete black box. If we continue with that, ops are not necessarily wrong in pushing back. So what can we do about it? It's really all about information, and it's not hard to put the information in there. I think if we really, as developers, if we get into the habit of starting to label containers, not only will ops feel more comfortable about putting those containers into production, there will also be a huge number of tools that will come out of, that will actually be able to work on and exploit the information that we're putting against containers, like being able to flag up when things shouldn't be in Germany or shouldn't be in the US, or you've got too many of them deployed and you don't have enough licenses, or exploits have been discovered in half of the containers you have in production. All of those tools are actually quite straightforward to write if you have consistent metadata in your containers. So, what are we doing about it? Well, we're part of a community project called label-schema.org. And we're trying to define a set of conventions. What are people doing that is best practice in the use of metadata at the moment, so that we can encourage other people to just do that too. And at the moment, we're keeping it really, really simple. It's like 10 basic labels that we recommend that you put in all of your, in your Docker files to put against all of your containers. Things like the name of the application, a tiny one-sentence description, what code it was built from, if it's available publicly, even if it's not available publicly. Small things, ideally point us to Dockerfile, maybe license information, although that actually is V2, that's more complicated. Just really, really basic stuff. If we can get into the habit of that, we can make that fully orchestrated future come about, and it's very, very easy to do. We also set up a tool called microbadger.com, where you can view the metadata associated with any public image. So that you can see what it is. You can look at your own images and see whether or not you have any metadata, and also whether that metadata is correct. Because when I said only 4% of images on Docker Hub have labels, actually another 3% have labels. It's just that those labels are wrong. Because they have been inherited from a base image and not overwritten, because you can inherit labels from your base images. And sometimes if you do that, those labels are totally inappropriate to the final container. So actually, there are almost as many mislabeled containers on Docker Hub as there are correctly labeled containers on Docker Hub. Go crazy, define a tagging policy. I think you'd find that useful. That would be quite good. And really try to maintain an actual maintainer. That would be that would definitely be useful. And again, incredibly, incredibly easy to do. So, I mean, here's an example of so Jetstack are just a small startup in the UK. They put a very basic. We just pulled up one of their images on Docker Hub using MicroBadger. You can see that they have, they've got no maintainer, interestingly enough. They've got a couple of tags. They are one of the 4%. They've got 3 labels in there, and you can see that they've got 6 layers. So nothing very complicated. All we're saying is put some labels in. It's easy. In the future, I would love to come back and talk to you about what amazing tools we can build with more advanced metadata. And I'm not even talking about crazily advanced metadata for that, just things like what service is this part of, for example. But I'm not going to talk about that, because what I really, really want to do now is encourage folk to just use basic labeling, basic container metadata. Easy to do. Will have a huge impact on the future. So yes, metadata for peace. This is, I think, utterly key to this fully orchestrated future. It's something for all of us to do. It's something any of us can do. It's very, very simple. It's nowhere near as complicated as writing a container engine or writing an orchestrator. But it will mean that in the future, other folk can write really clever tools like massively intelligent custom schedulers that will be able to manage your systems and your containers for you automatically. So there we go. I have to finish on the final slide, which is click to rate session. And does anybody have any questions? Lewis.
So do any of the schedulers yet have the ability to say, if it's not labeled, I won't run it? Do any of the schedulers yet have the ability to say, if this container is not labeled, I'm not going to run it?
Not yet, no. At the moment, it's actually, well, there's so few applications actually running. I mean, the orchestrators, a lot of them do actually start to set their own runtime labels. So what I'm talking about here is build time labels. A lot of the schedulers, like Kubernetes, will set runtime labels as well, and they define those themselves and apply them themselves, and they just apply to the lifetime of the container whilst it's running. But at the moment, nobody is mandating build time containers. It's too soon, isn't it? Because there's hardly anybody using them. But we are working to get automated labeling into some of the new open source container build tools. So hopefully there will be zero effort in doing this in future, but for the time being, there is some small amount of effort required to do it.
We have a question through the app. Can MicroBadger run against images in private repos?
Not yet, no. So we've only got public repo support at the moment, because that was easier, inevitably.
first, thank you. But then second, I guess my question is, how do you think about sort of the level of trust operators should place in developers to sort of correctly label versus, so I guess the question is like, for organizations going down this path, is it better to invest in automated tooling that lives in the CI/CD pipeline that is automatically tagging these things as it gets built and injecting basically licenses and SHAs and Git pads and things like that? Or do you go down the path of saying, these are labels that live in the Docker file that the developers sort of own? And I guess sort of the question becomes, how do you avoid the cargo culting where it's like, at some point every image has the same tags because they've just copy-pasted it and nothing is actually accurate?
Well, yes, because I say 4% of the images on Docker Hub have correct labels. 3.9% are just the labels that they've inherited from CentOS. They've cargo culted them in, and they're completely inappropriate to the final build container. Yes, I think in the long run, as I mentioned, the best solution here is to have labeling and tagging and maintainers built into your build tools. That is absolutely the right solution. But at the moment, that's quite slow going, and I think that we need to be shouting for it. As consumers, if we're saying, look, I would quite like this to be in my tools, then we're more likely to get it. Yeah, because in the long run, I don't really trust developers to do it either. I would much rather that it was in the build tools, yes. But at the moment, it's not in any build tools, so if we want to do it, we have to do it ourselves. And quite often, these things, you do it yourself, and then people realize that it's important, and then they build it into build tools.
More questions? Thank you very much.
Thank you very much.